Here is a second example on population growth, but now we're going to talk about bacteria in a problem, and we want to find the value of K. What is that percent of increase? And this is a growth, is a percentage of increase. So this is already in your notes. I just want to review with you for a minute. Y represents the end amount. C represents the initial amount. E is your 2.71. K represents your rate of increase or decrease. If your K is greater than 0, then it's a growth rate. If your K is less than 0, then it's a decay rate. And then your T is your time. So this is already in your notes. You don't need to write it down. All right, here's our example. A biologist is researching a newly discovered species of bacteria. At time of 0, he puts in 100 bacteria into what he has determined to be a favorable medium. So kind of highlighted in these colors are information. So time is 0, 0 hours. He puts in 100 bacteria. So that's our initial 100 bacteria. 6 hours later, so now we have a new time, it measures to be 450 bacteria. So now time has gone by to be 6 years. Sorry, 6 hours. Assuming exponential growth, what is the growth constant for this bacteria? Round to 2 decimal places. So we want to find out what is our K in this formula. So our end amount is 450 bacteria. Our initial amount is 100 bacteria. E raised to the K, and then time is 6 hours. And we want to solve this for K. So we're going to first divide both sides by 100. And then we are now have that 100 gone on the right. And then K times 6 is 6K. Now I'm just going to simplify that 450 divided by 100 is 4.5 e to the 6K. I'm going to multiply both sides by the natural log. The reason why I chose the natural log is the natural log and the exponential base e are inverses of each other. So what you're left with on the right, these two are inverses like we just talked about. We're just left with the 6K. It's not exponential anymore. And then on the right, it's the natural log of 4.5. Now to finish off the problem, we just divide both sides by 6. So it's the natural log of 4.5 divided by 6 equals K. Now we enter this into our calculator. The natural log of 4.5, make sure you have a parentheses after 4.5, divided by 6, gives us a value of K equaling 0.25067. If you wanted it as a percentage, it's about a 25% increase for every 1 hour. But they just wanted to know that the value of K.